Hello and welcome. So let's start with the Perceptron learning algorithm. So it is the hard form of logistic regression. So why hard form? If you have already gone through the logistic regression, then if you observe there that the output of the hypothesis function will varies from 0 to 1, right? But here in Perceptron, uh, that output of the hypothesis function is either 0 or 1. So it will take either 0 or exactly 0 or 1. So alright, so now how you can write this gz. So it will take 1 when z is greater than equals to 0 and 0 when z is less than 0. So but in case of, if you have already gone through the logistic regression, in case of gz was the sigmoid function and it was varying from 0 to 1. But here if you see that uh, the graph of this gz, it will be for less than 0 it is 0 and for greater than 0 it is 1, right? So it is there is some abrupt change here, right? So we can call it that it is the hard form of the logistic regression, right? Okay, so now here hypothesis function, that is h theta x is equal to g theta transpose x, right? And it is equal to 1 when theta transpose x is greater than equals to 0, and it is 0 when theta transpose x is less than equals to, so less than 0, right? So we are still looking at the binary classification, right? So that Perceptron learning algorithm, it works when we have the data set that is linearly separable. What I mean by that, so we will have this kind of data set, uh, so this kind of data set, and if you observe this data set is linearly separable, right? So you can apply this Perceptron algorithm to those kind of data set which are linearly separable, right? Okay, now let's jump how we can get this hypothesis function such that these two classes are getting classified. So also let me, before proceeding, this belongs to class 1, or we can say label 1, and this belongs to label 0, right? So what we need is this theta transpose x such that it classifies the two classes, right? So this line is theta transpose x is equal to 0, and from here it is that theta transpose x is greater than equals to 0, greater than 0, so that you are getting this class 1, right? And below this theta transpose x is less than 0, and you are getting this class 0, right? So we will have to find this parameter such that we have the separable classes or separate classes, right? Okay, so okay, let's take okay, what we will do, we will simply look at how this Perceptron works. And so we have already gone through the logistic regression, and there we have already seen the update rule, right? So it will have the same kind of update rule, but here there is some changes in the hypothesis function, but the update rule will be same, right? So we will have just change in our hypothesis function, right? So what was the update rule? So update rule for our parameters was the theta j old, sorry, new, theta j new is equal to theta j old plus alpha times, that is the learning rate, yi, that is the actual output of your any training example, that ith training example, minus this is the theta transpose xi xj yi. So and this is your estimated value for that particular x, right? So and here x j I, right? So this was the update rule. So according to this update, we want to achieve this theta such that we can separate these two classes, right? Okay, let's suppose we have this kind of data set, right? That is linearly separable, and we have to find this line such that we have the, right? So let's take this one, and okay, okay. So what we can do, this is your some feature x1 and x2, right? So we can pick any theta random, right? Theta, well, any theta is a random, right? Random value. So we can pick any random value, and corresponding to that we will get some line that will look like this, maybe. So this is h theta x, and that is equal to theta transpose x is equal to 0, this line, on this line, right? Also let me first of all classify according to our training example. So what training example says that this belongs to class 1 and this belongs to class 0, right? So this is okay. Now okay, so if what you will have to observe is this difference, right? So this yi is the actual output, right? So let's, so for this theta, if you look at the hypothesis function, so this particular example is getting classified wrong, right? This particular that one, right? And other have classified correctly. So let me first just explain this difference, then you will have the more idea, right? So for this particular example, if you see yi, that is the actual class that it belongs to, that is 1, right? So 1, and for this theta, how this hypothesis function have classified this. So above this is theta transpose x greater than 0, and below this theta transpose x less than 0. So if you see for theta transpose x greater than 0, it is classifying as g1, and for the less than 0 it is classifying as 0, right? So if you look at this particular point, that is this one, so it is less than 0. So right now this hypothesis function is classifying this as class 0, right? So here what it will be 0, right? So this one is 1, so 1 minus 0, that is 1, right? Okay, now let's take that is already in good position and it is already in correct class. So if you look at this belongs to class 1, right? So in actual it belongs to class 1, so yi will be 1. And how this hypothesis function have classified this example, that is theta transpose x is greater than 0, so 1 minus 1, that is 0. So we will have the 4 possibility for this difference, and I think you have already got the idea that in what cases this difference will be 1 or minus 1. So whenever we have the wrong classification by our hypothesis function, it will be either 1 or minus 1, right? And when we have the correct classification, then this difference will be 0, right? So I think you can visualize this and you can get this point, right? So now this whole difference is either 0, 1 or minus 1. So these are the cases when hypothesis function is not correctly classifying the examples, right? And if it is 0, then let's look at this theta j nu. If it is 0, then theta j nu will be equals to theta j old, right? And plus 0, this whole term will become 0 and there will be no update on the theta j nu. So algorithm will get to know that I will have to stop and there is no further update on the parameters, right? But if this theta j nu is 1 or minus 1, let's suppose it is 1, then this theta j nu will be equal to theta j old plus some alpha times x, that difference will be 1 and it will be xj I, right? Okay, now there would be some update on theta, right? There will be some update on theta here. So so let's see how this will work, that how this line will get shift, right? So let's visualize this one. Okay, so okay, okay, so this line is theta transpose x, right? And it is equals to 0 on this line, right? So that theta transpose vector will be perpendicular to this line. So this is the theta transpose, right? So that is the theta transpose old, right? Because it is perpendicular to on this line. Now this example has been classified as wrong, so now the theta nu will be this one, right? So it will add some vector to this old one, right? So it will add some vector that is alpha times x I j, right? So this is, and the whole addition will be this one, right? This one. So this this blue one is the theta transpose nu, right? And perpendicular to that is this line. Perpendicular to that vector, this green one, is this. So now if you see this theta transpose nu, theta transpose x, have classified this as a class 1 and this as the class 0. So So the overall point was, so what point I was making, that how this update works, right? So I hope I have make you understand. Okay, so that is all about the Perceptron learning algorithm. And okay, that is all from this. Okay, thank you.